तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करेंगे। इंसिडेंट वेव का इक्वेशन दिया है इन लोगों ने एंड म्यू टू और म्यू वन ए भी दिया है। तो बेसिकली दो रोप से, एक थिन रोप है और एक, तो यहाँ पे म्यू वन दिया है। म्यू वन मतलब लीनियर मास डेंसिटी ऑफ दिस थिनर रोप और म्यू टू मतलब लीनियर मास डेंसिटी ऑफ दिस थिकर रोप। तो उसका रिलेशनशिप दिया है और क्या बोला है कि फाइंड YR, that is a reflected wave equation, or YT, that is transmitted wave equation. So basically, when we create a wave in this thinner rope, it gets reflected as it gets transmitted as well in this thicker rope. So we know the equation of this incident wave, original wave, and then we have to find the equation for this reflected wave as well as transmitted wave. To solve this problem, you must know this formula. Amplitude of the reflected wave is given by V2 minus V1 divided by V1 plus V2 into AI, that is amplitude of incident wave. Amplitude of incident wave is 3, okay, and we don't know V2, V1. So let us see how we can do that. But before that, another formula is amplitude of the transmitted wave is given by 2V2 upon V1 plus V2 into AI, that is amplitude of incident wave. If you want to calculate the amplitude of reflected wave and the transmitted wave, you will need to find out this V1 and V2. Okay, velocity of the wave in the rarer medium and the denser medium. There is thinner rope and thicker rope. So out of this V1 is known. Velocity of this incident wave and velocity of the reflected wave is same. So if you can calculate velocity of the incident wave, we will know V1. So it will be given by omega divided by k. And omega is given as 4 in this equation. This is the omega. K is 2. So that way we have got the value of V1. Now another equation that you must know is phi is equal to under root of T divided by mu, where it is the tension in the string and mu is the linear mass density of the string. So once we know this equation, we can write phi1 divided by phi2 is equal to under root of T divided by mu1 divided by under root of T divided by mu2. So which comes out to be under root of mu2 upon mu1, and they have given this ratio mu2 upon mu1, okay, this ratio. So that way we will get phi1 is equal to phi2, and then phi2 will be 1 because phi1's value is 2. So we now know the phi2 and phi1 as well. So we can calculate amplitude of the reflected wave as well as amplitude of the transmitted wave. The equation of the transmitted wave is given by at into sine of k2x minus omega t. So at we have already calculated. Omega will be same as the incident wave. T we can write as it is. So only thing we have to calculate is k2 now. Okay. And how k2 can be calculated is using these equations. V1 is equal to f into lambda 1. So velocity of the wave is frequency into wavelength in the first incident wave, and V2 is equal to f into lambda 2. So we can take the ratios and then which gives lambda 1 upon lambda 2. But lambda 1 we know that 2 pi upon k1 and lambda 2 is 2 pi upon k2. So which comes out to be k2 upon k1. And out of this k1 value is given in the incident waves equation. So we can use that and then we can calculate k2. So after filling we will get the equation of the transmitted wave, and also for the reflected wave similar kind of equation can be written sine of kx plus omega t. So reflected wave is traveling in the negative x direction, that's why we will get plus sign over here. So that will be equal to minus sine of 2x plus 4t. So here minus sign, it's because there will be 180 degree of phase difference between the incident wave and reflected wave. Here there will be plus because wave is traveling in the negative x direction. Thanks for watching.